Okay, this is Charles Sterling from Sterling Power Products. Today we're going to do a little test to show which is the best fridge, which is the more economical fridge, how you can get, value for money if you want to go to 230 volt electrics on your vehicle or boat and run 240 volt fridges. So it's just really what it's about is comparing different types of fridges, 12 volt DC, 12 volt DC, 240 volt AC, running through a combined inverter charger. This is our new combined inverter charger with a very low quiescent current, so it can run a fridge, etc., etc. And then this is the gas electric, that's 240 volt and 12 volt absorption fridge, so a completely different technology. Now what we're going to do here is quite simple. Two basic tests. The first one is measuring the rate of drop of temperature against current, in other words, to see how the compressors perform. And then the second test will be a 24-hour test and see how much energy it uses, and that'll be the insulation test. So what we're doing here is we have put in an old battery charger we have, which is solid. It's the reason I want to do this is because we can read the temperature. It's a dark color, so I can easily read the temperature. Inside we have four bottles of water. So we'll put that there. And we've got 4 bottles of water inside each unit, and then we're going to put just some water to make ice. So we'll just make sure these are all full, which that one wasn't. The freezing compartment was so small, and some of them I had to get an ice machine or ice molds and then actually cut them down to make them fit. So, but they're all the same. I've cut them all the same, even though, for example, this one was quite small as well. So that'll fit in there. This one could have used a lot more ice. It's a big freezer compartment. And this one just needs topped up a little. Spilt some. Okay. And we'll put this one into the absorption fridge. This was the smallest one, so we had to make the ice mold to fit that. So we've got 4 bottles of water, let's call it the turkey, and the ice, the water in the ice making department. So what we're going to do now, quite simple, we're just going to run this for 1.5 hours. The fridges are on their maximum settings, or should I say their coldest settings, and all we want to see is what's the temperature drop versus how many amps are used. They're all pretty much the same size. This is the bigger one. These are about 46 litres, again about 48, about 40 or 38 or something, and I think this is about 50. So there's not that much difference in the size, not enough to make any sort of radical difference in anything. What we have here are 4 of our power management panels, and what they are measuring is the amps the compressor is actually taking, and then the amp hours, in other words, how many amps it's going to consume over that hour, because I've done a couple of tests on these, and I thought the fridges would work flat out until they reach temperature, but they don't, so the compressors are clearly overheating. The first stage is about the compressor. So let's just, and this is our battery charger, it was one of our ProCharge Ultras. It's just to maintain the voltage the same throughout the whole test. So they're all on the same voltage, they're all on the same everything. I'm just going to switch the power on. And that squeak was the inverter firing up. So let's just start the timer. And we're looking for 1.5 hours. And then what we'll do after that 1.5 hours is we will measure the temperature of each of those blocks, put it on our information thing here. I needed to get the temperature before we started, so I'll quickly open that up, get a temperature reading, and it's 20.6 degrees. So this was a test I'd done earlier, so we'll change that to 20.6 as our starting point. So we're starting at 20.6. Okay, so all we do now is leave it for an hour and a half. I'll just get some readings now from the various meters so we can know where we are from the point of view of the starting point. Well, this unit here is taking 2.7 amps, and that is the Waco running current is 2.7. Now this current tends to change a bit. This one is now at 2.9, which is that one there, 2.9. The unbranded 240 volt one running through the Combi is actually taking 5.9 amps. So that's taking 5.9 amps. And the Dometic, or this absorption one, is taking 12.3 amps. So on the surface, this seems bad, and this seems to be the sort of norm. But we don't know whether it'll all be down to the temperature drop. So this could be looking bad from the point of view of current, but it could be doing a lot more work and dropping the temperature more. We will find that out after 1.5 hours and we do the calculation. Because there's two aspects to it, or three aspects. There's the motor, the compression cycle, and the insulation. Well, you can see the insulation on these. It looks very good. You can't actually see the insulation on this because it's built in, so we don't know whether it's good or not. And the insulation on this looks good as well. So the insulation factor is obviously relevant. Then there's the compressor. So this is a 12 volt compressor versus a 240 volt compressor. This is an ammonia system working on absorption type principle. Genuinely, you don't expect this to do very well, but we're putting the test anyway as a reference point. So it'll really be down to, you might have good insulation here, but the 12 volt compressor will not be as efficient as a 240 volt compressor. So whether one balances the other out, we will find out. So the first test won't tell us that. The first test will just tell us which compressor is better, or which has been the most efficient compressor. The second test will be the 24-hour test. After we have cooled everything down, we'll just run it for 24 hours, and that will tell us which one has the better insulation. So we'll get the two things, and then we can check the data. So it's all about the data. It's not about a personal choice. But what we're trying to promote here is, if it works, is if you look at this board here, this is the rough cost of the fridges. They're around the 500 to 600 pounds mark. A Combi is about 828 pounds. So if the 75 pound fridge does as well as these other ones, then literally you can save 500 pounds off the Combi and get 240 volts on board. Obviously, this is not here just to run the fridge. That wouldn't be that clever. Unless, of course, you've got bigger fridges that are 1600 watt or 1600 pounds. It makes perfect sense just to put an inverter on to run your fridge, because you'll save £1,000. But this is not what we're after here. What we're trying to say to people is, we want you to get your hair dry, your vacuum cleaner, your microwave, all the other stuff on board. And this is just a way of reducing your costs. In other words, if we can prove that if you fit a Combi, there's absolutely no point in fitting a 12 volt fridge. We don't have the maths to prove that yet, but we're on our way. So we're in 4 or 5 minutes. We're going to do 1.5 hours. Then I will come back and I will take the readings, and we'll take it from there. So I'll disappear now for an hour and a half. Okay, we're back after an hour and a half, pretty much exactly. It says half an hour there, it's been round once and a half. So an hour and a half. So what I'm going to do now is take the temperatures of the turkey and just see how much everything has dropped in temperature and the amp hours consumed. So, and if there's any ice. So let's see what we are at amp hours first. I'll do this in red. So while I was off camera, I took more readings of the current at different times during the event, and this is like 11 amps all the time. This one's varying from 2.7 to 3.6. This one's 2.9 to 4. This one's 5.9 to 6.7. So they're coming on and off, and there is slight variations in the current consumption. So the first thing we're going to do is the amp hours used. This one is saying -5, -5, -5 and 17. So that's pretty simple. So absorption was 17 amp hours. The wake up was 5, 5, and 5. So these are all obviously something similar size of compressors. Now let's check the efficiencies. In other words, what temperature have they dropped and did they make any ice? So let's see. The turkey is 18 degrees. Is there any ice? Aha. 18 degrees and ice. Oh, well, it's not solid. I can break the top of it. So there is ice, but 3 of them have no ice on it. So yeah, it's making ice, but certainly isn't all ice. But what I said the temperature was 18 degrees. So let's write that down. So that one is 18 degrees. Seems a bit, let's try this one. Right, the turkey is 12.4. Ice is certainly on the top, but I can put my thumb through it. So there's ice on the top, but not solid. But it's certainly a lot colder at 12.4. 12.4, that is, sorry, that's the wrong one, isn't it? Where's my 18, a little bit of ice. So that's 18, so light ice. And that one there was, let's check that again, which is 12.4. $11.8. So that one is 11.8. So that's light ice. Let's just check. That seems very high at 18. I'd have thought it'd be better than that. Let's just check that again. No, same again. 17.7. So yeah, surprisingly, I'll leave it at 18. Unbranded one. Right, dramatic difference. 6.7. So that one is 6.7 degrees. And what about the ice? Again, on the top, but breaking it. So there is ice, but it certainly isn't solid either. So, yeah. So 6.7 and light ice. So they've all got the same sort of ice, not fully iced by any stretch of the imagination, but certainly there's ice on it. This one here is no point even taking that out. That's just pure water, no sign of ice on it whatsoever. Certainly coldish. And the turkey is 16.5. So that one is absorption 16.5. Okay, so what's this telling us? Let's do the maths. We started off at 20.9, we're down at 16.5, so that is a drop off, so it's a different colour. So we're dropping 17.3. I'll just get a calculator to sort that out just in case I do something stupid. So 16.5 or 20.6 minus 16.5 So that's dropping 4.1. So we'll do that in blue. 4.1 is the drop. We'll forget the ices there. So the 20.6 there is 2.6, which is 2.6. The other one is, I'll do the calculator, 20.6 minus 11.8. That's 8.8. That's dropped 8.8. And then the other one, the unbranded one, is 20.6 minus 6.7. 13.9 degrees. I'm just going to check this one again because that does seem particularly bad. Let's just make sure we're getting that right because I don't want to. Okay. It's dropped a little bit down to 17.1 now, so right, so let's make it 17 just to give it the benefit of the doubt. 17. So that makes that 3.6. It's dropped. Okay, that's giving it the benefit of the doubt. Right, so again, the amount of degrees it's dropped really doesn't mean anything. It's amount of degrees it's dropped per amp that you have consumed. So we will divide the degrees into the amps and see what we end up with. What the real important figure is. So 17 divided by 4.1. So that's 12.9. So that's 12.9 amps it took. That's not right. Hang on, let's do that calculation correct. So 17 amps divided by 4.1. So it's 4.1. So it's 4.1. 4.1 amps to drop 1 degree. So 5 divided by 3.6. So that's 1.38 amps. 1.38 amps to drop 1 degree. 5 divided by 8.8. 0.56. And 5 divided by 6.7, 0.72. Stupid, not by, it's 5 divided by 13.9. 5 divided by 9 equals 0.359, so 0.36. Okay, so although they were using the same sort of current, the on-off times must have been different. The end result is, although this seemed to be using more current when it was actually on, it was obviously cycling more. And the end result is this has dropped 1 degree by using 0.36 amps, 0.56 amps, blah, blah, blah. So this is even going through the Combi, which the Combi would account for 0.5 amps in the hour. So that would be about, the machine itself would probably be about, the compressor about 0.2 2.27 amps was actually what the compressor was using. So clearly the 240 volt compressor is a lot more efficient than the 12 volt compressor. It's got nothing to do with the refrigeration cycle. That'll be exactly the same on both of them. This is just purely down to the compressor. So anyone that tells you that a 12 volt compressor is more efficient than a 240 volt compressor is talking absolute nonsense. So this Waco one is the older fashioned type. This has got some new sort of control system on it. But the old one was 1.38 and this is 0.56. At the end of the day, the 240 volt fridge compressor is so much more efficient that even through the inverter, it's using less power to drop 1 degree C. So that surprises me, it was that inefficient. But anyway, these are the figures. So one day if you want to try this yourself, go ahead. So the next test is going to be, let's give these fridges a chance to drop down in temperature a lot more. And then the next test is going to be purely insulation. And once we get the temperatures down, we'll sort of take the temperatures before the test and then 12, 15, 20 hours later, whatever time we get in tomorrow, we will take the temperature after the test to make sure there's not much variation in the temperature, but we will be interested in the actual amp hours used over that 24-hour period. So I say, from what we can see here, the absorption fridge, the difference between the absorption fridge and the 240 volt compressor fridge is nearly 10 times more efficient, the 240 volt compressor fridge. So these things just seem, the absorption fridges just seem to be using power continually, just going and going all the time, no rest. The figures from that thing are going to be atrocious. But then bear in mind, it's horses for courses. This isn't saying this is the best or this is the best or this is the best. It's horses for courses. If you have a camper van and you want gas on board because you're using gas cooking and you're going from site to site, there's absolutely nothing wrong with these fridges whatsoever. You don't want 240 volts on your vehicle or your boat, go with that. If you want no gas on board and you want no 240 volts on board, you don't want any 240 volts, that's fine, then absolutely you go with your compressor fridges. But if you want 240 volts on board, it does seem to be totally pointless fitting a decent Combi or an inverter, but with a low quiescent, it just seems pointless, and not fitting a 240 volt fridge, because the money you'll save on the fridge will compensate for the cost of the Combi. So that's really what this test is showing, that it is actually more efficient to actually go that way, but obviously the Combi would add the extra cost on. Now, so I say it's not that simple. Let's do the 24-hour test, because that's also important. If you're parked up somewhere and you're just running purely off your batteries, the 24-hour test will be the important thing. And that will also prove the insulation. We have no way of proving that this insulation here is any better than this one here. Maybe it is. But if the compressor is so inefficient, the refrigeration is fairly irrelevant. Right, so what I'm going to do is just leave this now for another hour or so before I go home. I will then come in, just measure the temperatures, switch the thing off, switch it back on again, reset all the counters, and just literally leave it all night. And come back the next day and see where we are. So just going to leave that, let it all cool down more, and do the next test in an hour or so. Okay. Alright, this is about an hour later on. Basically, it's 4:30, we're shutting down for the night, we're going home. So what I'm going to do now is basically do an overnight test. I would have liked these to have all come down to temperature. I can't say they are, but what I will do is take the temperature now and the temperature tomorrow morning, because what we're trying to show is if there's no temperature drop, then all the energy being used is purely to replace heat loss. In other words, it's all about heat loss through the product combined with the efficiency of the compressor. So really all the energy will be used just to keep it there. Now, because I'm pretty sure they won't be down to temperature based on the figures I got before, we'll just have to take the temperature where it is, and then tomorrow morning when I come in, I'll do those results, and then I will do the timer again and carry on maybe for another 4 or 5 hours, which will confirm our figures, etc., where we should definitely be down to temperature by then. So we can't be more than half an hour behind each other here. But anyway, we are where we are, and I'm going home. So the first thing to do here is write down where the amp hours are this particular minute. So this one's at 899. So amp hours are in blue. So the Waco one is at the start is 8. The Dometic was 9. Just make sure about that. And this one is 9. So that's wrong there. So that's 9 there. It's not the Dometic absorption. The Dometic absorption is at 31. I mean, that one has just basically lost the plot. But we'll just keep it running, as in, why not? That one is 9. Dometic compressor is 9 and 8. So that's correct. So 31 amp hour counter at the start of this next test, which will be for 15 hours until I come in the morning. So we'll do the next morning amp hour counter. So the next thing is, will the temperature have changed? So we want the temperature now, and hopefully it'll be, you know, close to where it'll be tomorrow morning. This one has just been appalling performance. So this one at the minute is reading 16.2, so there's no way it's down to temperature. So write that down. So before is Waco 16.2. That is pretty grim. Dometic compressor, it should be a lot better. This one here. Oh. .5, so it's getting closer to where we would want it to be. Let's put all this back together again. So that's all still working. So 8.5, Dometic compressor 8.5. Okay, and the unbranded thing here. 6.6. So that one is 6.6. I think that's actually down at its temperature. And finally the absorption fridge, which I'm sure will be very amusing if nothing else. 14.6. Okay. To be fair here, there's something very strange and startling going on with this one here. Whether a seal's broken or something, I don't know, but that's pretty poor performance. I would definitely give that one the benefit of the doubt somewhere. Anyway, it's there. We'll carry on with the test. So really the two main things here to look for. This is the latest up-to-date, brand new Dometic 12-volt fridge compressor. This is, as I say, the eBay 75 quid special. And then this is the latest up-to-date Dometic absorption fridge. So really it's these three fridges here. This one's obviously a little bit older, and its performance figures for a compressor fridge compared to the other one are pretty grim, but let's see tomorrow morning. So I've got the starting temperatures, we've got the starting amp hour counters, we've got the time we've started is 16:30, and that's on, this is Wednesday night. So tomorrow morning when I come in out of bed, we'll get some figures and do the maths there. And then we'll also do another 8 hours tomorrow, just to, you know, these fridges will be down to temperature then, so there'll be no sort of arguing. We'll just do a few more hours to confirm some of the figures. And then that's really those tests done. We'll have all our answers tomorrow. Okay, it's now 7 o'clock in the morning, the next day. So let's take some readings. So we started at 16:30 for these readings, so we're going to read at 07:06 0.00. So we'll work out how many hours that is, and let's go again for the that's the temperature and that's the amps. I'm just going to do an amp reading at 7:30. So the amps are 50 amp hours on the Waco 50.0. So Waco finish there is 50. The Dometic is 41. So that is 41. Unbranded is 40. Unbranded is 40. And the, oh my God, 203. So 203. Right, let's just put a little line at that. So this amp hour has just been counting through all these tests. No one's stopped it. So that's that one, that's that one. So as it stands at the moment, this one here, which is the 12-volt compressor, started 9, finished at 41. The 240-volt one started at 9 and finished at 40. So now we just have to check the temperatures to see if it's been holding the temperatures or if something weird's been going on. So the temperature for this machine here now is 0.4 degrees. Dometic, that was the Waco 0.4. So that's down now to 0.4. Okay, that's this one here. .4. So let's close this back up again. .4, 1.4. And this one here. .2. And finally, .1 degree. So that's it. 1. So they're all well down now, so there's no more. So the next test we'll do, I'll just run it for the next 8 hours and we'll see how many more amp hours it uses. So we're definitely on to the, what do we call it? The compressor's done all its thing. We're right down to temperature. So we'll run it for another 8 hours or so, and that'll tell us exactly. At the minute, it's showing that, I'll do the maths for that. Hang on, let's see. Okay, now I've got all those calculations out of the way, so let's see what we got out of that. So the total time run last night was 16.5 hours. We've measured the amp hour, or the amps consumed in total for this morning. So we subtract that from what the amps were last night. 31 there, 203 there, 8 amps last night, 50 amps this morning, 9 last night, 41, 9 last night, 40. So we then divide in the number of hours and we get 10.4 amp hours used for the absorption fridge, which is what we seem to expect. It just seems to be continually taking around 10 to 11 amps. This fridge here is down to 1.9 amp hours. This one here is down to 1.9 amp hours, and this one is actually was about 1.87, but you know, we're not going to fall out of a 0.01, so I'll call it 1.9 as well, which is quite surprising. So we're down to the famous 2 amps per hour, which is what these fridges claim to be using. These fridges sort of claim the 2 amps per hour, and they're getting the 2 amps per hour. Here we are. The temperatures are all down to temperature. We're never going to get the thermostats all set the same. So, you know, this one here's temperature is 0.4. This one's 1.4. This one's 0.2. And this one's at 1 degree. So we're all around the 1 degree here, not going to fall out again over that. So the last test I'm going to do, so we've got this down to the 1.9 amps per hour. So far it seems that the actual, what do you call it, the insulation aspect in conjunction with the compressor is keeping them at the 1.9. So when we checked out earlier, the compressor efficiency was definitely best on this one, but now it looks like these ones have caught up. So these ones have probably got better insulation than this one. So we're down to this, but we're still at the same 1.9. So all we can say at the moment is there's absolutely no efficiency difference between 12 volt only and 12 volt put through an inverter, or in this case a Combi. It is worth noting at this stage that, again, as I say, this has got a low quiescent current of 0.5 amps. So this figure here includes the 0.5 amps for consumption of this here. So really, if you were to take the 0.5 off this, this would be at 1.3 amp or 1.4 amps. So in actual fact, if you just take the actual fridge and the electric motor, etc., this is way more efficient. This is 1.4 amps, and these are all 1.9. So from purely fridge to fridge, the 240 volt one is clearly the winner as far as efficiency goes, but you're adding on an extra 0.5 of an amp, which actually brings it up to the same as these. So anyone that tells you that a 12 volt fridge is more efficient than a 240 volt fridge, absolute nonsense. It just isn't. And I think the thing that seems to be letting it down is the compressor. It's just grossly more inefficient. It's a 12 volt electric motor versus a 230 volt electric motor. Anyone with any electrical experience will tell you that's a no-brainer. 12 volt electric motors, not good. So I think we've proved here, but what I'm going to do now is just run it, because we're all down to the 1 degree thing. I'm just going to run it for another, it's 7 o'clock in the morning. I'll run it until this afternoon sometime and do some more figures and see if the amp hour rating changes. But as it stands at the minute, from the actual performance point of view, 6 to 1, half a dozen of the other. So then you have to bring in the maths point of view. If you're if you're putting a good Combi on board your vessel, this proves beyond doubt that there's no point putting a 12 volt fridge. As long as it's got a low quiescent current. I cannot emphasize that enough. As I say, this one's 0.5, 0.6. Our other Combi would be 1.3, so that would be an extra 0.6. So those figures would go up by 0.6. So then this would be 2.4 versus 1.9. Having said that, the figures are still so low that if you're saving £400 or £500 on a fridge, is 0.5 of an amp going to make a difference? Anyway, this is the whole point of doing this thing. It's your choice. But certainly on the low quiescent current at around 0.5, 0.6, it is pretty much exactly the same. So I'm going to sign off again for another 7 or 8 hours, or until, going home this afternoon. Okay, Charles Sterling back again. I put the time down first this time. It's now 15:30, so it's 8.5 hours since we started this morning. So what we're going to do now is, we know what the temperature was, 1 degree, 0.4, 1.4, blah, blah. So we'll just check the temperature again and put it underneath here for this test here. So the second temperature I will put in brown. Let's call it T2. But just before we put the temperature in, I'll put the amp hour counter reading. So up here we have 71. Automatic compressor, we're now at 71. Absorption, we are at exactly minus 300. Automatic compressor, we are at 54. And the unbranded one is at 56. Okay, so let's see what the temperatures are like. Let's see. One 1.5. 1.5 and 0.8. So the temperature's in red. So 1.5 is this one, and 0.8 is that one. 8. And this one here is 1.6, and this one here is minus 0.7. 1.6 minus 0.7. Unbranded is 1.6 and minus 0.7. So clearly this this absorption fridge just keeps going and going and going and going at 10 amps. It's actually now into the minus. I don't know why they don't do some sort of regulator on it, but to be fair, you've used 300 amps so far to here versus 56 for the other one. So it's this is for the whole test. So since we started yesterday, this has used 300 amps, 71, 54, 56. So there's really, these two here are the key ones worth putting a little bit of attention to. So 54 and 56, no one's going to lose any sleep over this. Let's call them the same. In reality, you could go ahead and argue that because this has the Combi running all the time, there's two modes to this Combi. There's running all the time, and then there's what's known as power saver mode. Had we put it on power saver mode, the consumption is 0.1 of an amp off load, and then the 5 or 6 amps on load. Well, it's only on load for 1/3 of each hour, so we could have got those figures down quite dramatically by putting it on the power saver mode. But anyway, we chose to do it at the full amount, so as not to be seen to be trying to fake something. So in conclusion then, I suppose we should divide the subtract this from this and divide, and we'll see how many amp hours were used over the last 8.5 hours, which will be a reflection of the thermal efficiency of the installation. This one's not even worth doing because it's just working all the time aimlessly. So I'm going to do some calculations, so I'm sure they'll edit this bit out. Okay, we're back again. I've done a few calculations here. So first of all, from the last test we did, we've run an extra 8.5 hours from this morning. So we're sort of trying to check the actual thermal conductivity of the insulation, etc. So what we're doing here is measuring how many amp hours we've used in the last 8.5 hours. So the absorption fridge has used 97 amps. Divided by 8.5 hours, we get 11 amp hours. So that's the sort of 11 amp hours there. That's that relevant reading. The second one has used between 50 it started off at, 71 it's now, so that used 21 divided by 8.5 is 2.4 amp hours, 1.5 amp hours, and the bottom one 1.8 amp hours. Okay, so that was for the thermal. So bear in mind there's an amp or so with these meters, they're only reading by amps and not reading by point of an amp. So 1.5, 1.8, it's within 6 inches. As I said before, this includes the consumption of this unit here. Now, because the amp hours have been running the whole time, we started playing around with this yesterday at 14:30. It's now, 16:30, it's now 15:30, so 23 hours. So I've taken 23 hours and divided it into the total amount of amps from when we switched the thing on yesterday. It's been running all the time, and I've just measured the amps through all the tests, through everything. So it's the overall thing between the compressor, the insulation, blah, blah, blah. It's the whole lot. So I've taken all the amp hours and divided it by the total amount of time, which was 23 hours these things have been running, starting from cold or starting from empty with all the junk in them. So when you actually do the maths for that, this unit here has averaged out at 13 amps per hour, which is pretty appalling. The small compressor fridge has averaged out around 3 amps per hour. The bigger Dometic, which is the later one, is averaged out around 2.3 amps per hour, and this one, the 240 volt one with the Combi, has averaged out around 2.4 amps per hour. So really between these two here, we're not losing any sleep over the difference. Whether one's got a better compressor, one's got better insulation, it really doesn't matter. The end result is 6 to 1, half a dozen the other. So the idea that a 12 volt fridge is more efficient than a 240 volt fridge is absolute nonsense. They're either the same, and if you want to actually be pedantic and talk about the fridge only, there's no question the 240 volt fridge. Take away the 0.5 of an amp that this thing's drawing, and instead of being 2.4 would be 1.9, which would have been a clear winner. So the 240 volt fridge is more efficient than the 12 volt fridge. There's no question about that. Right, so we've established that, which was never actually the main cause behind that. So I'm going to switch all this off. I don't think there's anything else we need to prove really. So to carry on to the next level, which is the whole point of this in the first place. Now, I suppose I should do what I would call my recommendation. So if you are a camper van or a boat and you have no interest in not having gas, so if you have gas on board and you're going from site to site, there's absolutely, this is the fridge to have, because you know it's going to run off the gas. It's going to be completely inefficient when you're in 12 volts. You're not going to be in 12 volts that long. You're only going between site to site. Who cares? That's the one to be looking at. Unless, of course, you're on like a caravan where you would have trouble getting this amount of juice down your caravan cable. So as a caravaner, I'm not sure it would go down that route, but that's a choice. The next thing would be if you have a caravan, camper van, boat, and you're not particularly fussed on the gas, and you're going to run 12 volt, and even when you're plugged into shore power, you're running 12 volt, you want to do a bit more wide side camping, and you want to get gas off your boat or your camper van, then 12 volt fridge. It's in, it's done, and you've got no interest in 240 volts, you're just interested in 12 volts only. This is the thing to look at. If, however, which is what we've been trying to encourage, you want to start putting 240 volts on your vehicle, your boat, to run other things like hair dryers, vacuum cleaners, straighteners, coffee machines, etc., and you want to go down the inverter or Combi route, 240 volt fridge. If you're putting I can't emphasize enough the quiescent current. The quiescent current is the current that the Combi or the inverter will take when producing 240 volts but not doing any real work. So this has got a very low quiescent current of about 0.6 of an amp. If you have a Combi that's got 2 amps or 3 amps, all these figures go out the window, okay? So this is a 0.6, and even your average inverter, you would need something like a 1000 watt inverter just to run that fridge. That'll be about 0.9. So again, this is 0.6. That's important. Right, so then I would get this on, and if you're putting a Combi on like this, then there's absolutely no point wasting £500 for a fridge when £100 will do the job. It saves you £400 against this. The only downside with these fridges is these have got these locking systems on, so that if you're going around corners or waves on a boat, the fridge door doesn't fly open. Very good point. However, a £3.50 child safety lock on the side of this here turns your fridge door into one of these here. So an extra £3.50 isn't going to kill you. Child safety lock, you now have your door that locks and will not open when you go around corners, etc., etc. So I'm sure one day someone will make this type of fridge in 240 volts, but I say, just to prove the point, I bought this off eBay. Nothing special, not trying to sell them, don't care what you use, but we're just going by the principle. So we've covered the fridges, I hope, up to here. So really we're going to now show really why you want this on your camper van or your little boat or whatever. I'm just going to move this out of the way. I'm pulling the fridge plug out just because. So the fridge is no longer connected to it. And I've just got a couple of things here. So this is a Tresemme 2000 watt hair dryer. Not much use to me, I might add, but the ladies do like their hair dryers, or you want to dry the kids' hair while you're at the beach or something. Now, there's 2 settings on this. One's 1500 and one's 2000 watts. Bear in mind this unit is 1300 watts continuous, 1600 VA. So let's just put that in. That will have no trouble coping with microwaves and anything around 1000. Get a 1000 watt kettle, you have no trouble. Now, I've never tried this, so what I'm going to do is first of all put this on 1500 watts, bearing in mind it's only supposed to be, right, so that's on the lower setting, which is 1500 watts. It's a brand new unit, so technically if that was a low cost inverter that wouldn't even run. So I'm going to kick it up to 2000 watts. That is a Tresemme 2000 watts. I don't expect this to run it, so if it switches off, no shock. I'm putting it up to 2000. So there you go, so it's tripped out. So at 2000 watts, it didn't like that. But it seemed to be not too bad. When you trip these out, you have to switch them off and reset them again. That's a legal requirement. And then it'll go on to the 1500 watts, and it's working 1500 watts. So 1500 watt hair dryers. Of course, the other thing the ladies like is they like their straighteners. So these are top of the range, gold, platinum, something or other for hair straighteners. Clearly not something I'm going to be using myself. And difficult to make these work if you haven't got a pure sine wave inverter. And there's a button here somewhere. It's making lots of noise. So it's making the noise, it's lighting up. So I can only assume this is going to work. Yes, that's hot already. So these are ceramic. I'm told by the ladies in the place in the office that these are, you know, top of the range. So no problem with the hair straighteners. 1 kilowatt to 1.5 kilowatt kettle, off you go. And 1.5 coffee machine. So that's the point in having this here. It'll obviously run your vacuum cleaner, just your general day-to-day stuff. Instead of buying a 2.5 kilowatt kettle, just simply buy a 1 kilowatt kettle or a 1.2 kilowatt. It will even run a washing machine. If you get one of the low-powered washing machines that run on 1300 watts, this will run your washing machine. So this costs £828 retail. So again, if you're taking £400 off, it's costing you £400. If you want 240 volts in your boat or vehicle or whatever, it's a no-brainer. This is the point why I'm doing all this here. And the other thing to bear in mind is, even if you go for the bigger version, we do a 2.5 kilowatt version, its quiescent current is 1.3 amps. So if you go to your figure here, instead of using 1.8 amps per hour, it will use an extra 1.3 minus 0.6, so 0.7, so it will be using 2.3 amp hours instead of 1.8. It's not a deal breaker, but if you use these bigger fridges, which in this type here can be costing you £1,600, £1,000 to £1,600 for bigger fridges, then these become no-brainers. I mean, you're actually getting the fridge, you're getting the unit free. Instead of paying 1,600 quid for a 12 volt fridge, go buy a 240 volt fridge the size you want, slap one of these on, and you're actually walking out quids in, not even worrying about whether you use the 240 volts or not. So these are all things to think about. I'd like to thank the two distribution companies that we work with who lent us the equipment. In fact, they're coming down tomorrow. We've got Myriad and Arley International. So they were very interested in these results, because certainly for things like Arley, which is Midland Chandlers, they do a lot of narrow boats. Well, the fact that the fridge doesn't have a locking mechanism on it is of no relevance. It's not like your, you know, big waves or anything. So they sell a lot of our Combis. So they can go back to their boat builders and go, hey, look, there's no point wasting £400 on this fridge, or 500, whatever. If you're putting the Combis in, as long as they've got low quiescent current, just put a 240 volt fridge in, which is what we've been saying for years. But I never actually spent the time to get the figures. It was all assumption. It was all my opinion. Well, no more my opinion, no more assumption. The figures are here, the facts are in. So there's all the maths, there's all the figures, and you know, I'm done. So if there's anything else you want, give us a shout, and hopefully we can help you. All right, thanks then, bye.